Hi guys, this is part 3 of the tree CNC video. First of all, I have to give a big shout out and thank you to Benjamin and his brother Nick for setting me up with the manuals for the machine, programming manual for the controller, and the electrical drawings for the machine. That's a huge help. Thank you very much. If anyone wants to take a look at the manuals, I've included links to them in the video description. The next order of business, I think, is going to be looking at the spindle bearings, because I noticed that I was doing some I left the spindle running at about 3000 RPM for a while, and it had gotten very hot. It had actually gotten so hot that the tool in the taper, basically the spindle expanded a bit. The tool moved up in the taper slightly, and when it cooled back down, it wouldn't come out. I had to actually get in there and carefully pry it out to get it back out. So definitely the bearings in the bottom end of this, they were slightly noisy. You can sort of hear a slight noise, and they're getting very, very hot. So I believe I might just try lubricating them first. Actually, first thing might be just to see how much vertical play there is in this. Like, just set up a lever and try pushing the spindle up and down. If it's not too bad, it might be just a case of getting some lubrication into these. Okay, so we are getting some play when loading this down. 3 thou or so. Actually, I shouldn't have turned the servo drives off, because now we're actually moving it. Just turn them back on again. I just did that to try to reduce that horrible squealing noise, but it looks like we're going to have to leave them on. But anyway, we get about 2 or 3 thou play on this while loading this down, but I also measured it up here at the spindle. We're getting something similar around there, so it does not appear to be the spindle bearings that are causing this. It's also suspiciously linear with respect to how much force you apply to this, so I'm thinking it's actually deflection somewhere, either in the ball screw, or I don't think the whole machine casting would deflect. I can't see that. I have locked the table lock here, so that's not moving. But so the spindle bearings, if the spindle bearings are worn, I'd expect some sort of large movement as you overcame the weight of the spindle itself. So it seems the play in the spindle bearings is okay. So hopefully it's just a case of relubricating them. This is starting to come out now. I got the snap ring off, although it's a really big one. I had to buy some new pliers for that. And then I just basically loosened, clamped the ring down, and then hammered on the top of this shaft with a rubber mallet. Now let's see if we can start getting this farther out. Looks like that snap ring is not going to come off. Oh, there it is. Okay. Yeah, this is the seal. It's not really a seal, it's more like a, what do you call it, just a cover. It doesn't actually have any sort of rubber seal. And there looks like the bearing grease, which is all completely gray. Let's continue taking this down. There we go. How heavy is this? Not too bad. Okay. I think this is the part of the retention mechanism. What I believe is this a piston pushes this part down, which releases the mechanism. But the springs are very strong. I can't seem to push it by myself. Now to get this out, probably gonna have to lower the table. I have to turn on the machine to move it around. Let's just yeah, I think it'll be easiest. Yes. Yeah, the grease in here does appear to be in really bad condition. Like, it's really thick. It's full of filings. So definitely these bearings have seen better days. And also, they feel very, very rough and very. There's a lot of friction, which explains all the heat. So let's see. It looks like according to the drawing, we'll have to take off this. This clamping part here to get in the bearings will come off this way. But clearly, this is all one part. All spindle's one part up to here. So, yeah, let's. I'm thinking these set screws are going to have to come out, and then this thing will unscrew. Probably, actually, this will have to come off first because the springs are preloading it. Yep. Here's a slightly better view of the bearings. Doesn't look too bad. A lot of caked on grease around the side. These are angular contact bearings. One of them is designed to handle thrust one way, the other thrust the other way, so two of them together sort of lock the spindle in place. Yeah, the top bearing seems in relatively good condition. Like, it feels pretty smooth. The bottom bearing has all the bad really bad grease in it and is quite rough and has a lot of friction. I'll give it a try cleaning these. I had this was coming apart earlier, although I can't seem to get it to come apart now. But I think we can completely disassemble the bearings just by pulling them out, because they only have contact on one side basically. Yeah, it's not too hard. Bearings flying out. Probably do this in some solvent. Okay, these are all clean now. So we'll start reassembling this. So this says thrust here. It obviously thrusts against this ring, so it has to go in this way. I found the best way is to actually, let's see. Yeah, this has to go. This ring has to go on this side, so it goes in like this. The best way is to put the balls in top half first, holding it as high as possible. I think we get one more. Then this goes in like this. And now the rest can go in. Oops, just trying to drop balls there. Make sure those are clean. And the last one. There we go. Now we got to sort of roll it back in, or actually last time what I did was just tap it with a bit of brass. There we go. Yeah, still rather noisy. Let's get a bit of oil in there, see if it's any better. Okay, that's quite a bit better now. And let's put some grease into these. This is the closest stuff I had to what is the consistency, what the consistency was in those bearings. So let's give this a try. I think these bearings are pretty much on their last leg, so I'll see if I can get any more life out of them until I can order in the new ones. Replacements are something on the order of $30 each for sort of lower end ones. Not too bad. Although I've seen some higher end ones of this size go for $500 each. Wondering if that kind of precision is actually needed. A little bit concerned about the relatively high friction this grease is causing. I wonder if the spindle's still going to have that overheating problem. Make sure the surface around here is clean so that the bearings seat on each other properly. Because the angular contact bearings are designed to seat right against each other to sort of take up the play, and they have to be clean to make sure they seat properly against each other. cleaned the wrong side actually. Just pack a little bit. The grease should be okay. Don't want to pack too much in, or there'll be too much friction. That's on right. There we go. Okay, let's see if the drawbar works. Seems to work properly still. And slowly, let's turn that up a little bit. I'm hearing a little bit of a rubbing noise in there, which is not good. Okay, whatever that noise was seems to have gone away, and I can run the spindle all the way up to full speed now. It sounds different than before, a little bit better, although it's still, these bearings definitely on their last legs. I'll have to get new ones, but this will hold out for now, I think. Spindle overheating problem seems to be solved now. This has been running for about 10 or 15 minutes and it's barely even warm. Okay, the next thing is going to be to look at these sort of graunchy bearings for the y-axis. I pulled them out already, but one over by the table, and this is the ball screw itself is pretty smooth and feels very tight. So I'm thinking these bad bearings might be where that that backlash was coming from. This is just the belt drive, and these are the taper lock pulley, a little thing that held the bearings in, so it's pretty easy to get out actually. They don't seem to have paid really any attention to sealing the bearings in this machine. These are completely unsealed, and this is open into the central area of the knee of the machine, so there's filings and things getting into it. So these are 20 by 47 by 13.86 millimeter bearings. The thickness was rather weird. It's not any convenient number in imperial or metric. One of them's, this one's pretty good, not too bad. The other one's quite nowhere near as good. This one's It'll hold out for now. I'll put some grease in, but at least now I know the size I can order them. Okay, I've cleaned out all the debris I can from in there, so we should now be able to put the bearings on. Seems to fit. A little bit of a... Come on. There we go. Okay. Push that in. Then the bushing can go back on. Actually, no, the pulley. Actually, first I got to clean off the grease in here, because if that grease might result in a poor friction fit. Finally, the spacers and the nuts. Okay, the first one is going to control the for the preload on the bearings. That's about as tight as it was when I did that. Seems to be working pretty well. There we go. And how's the positioning? Looks pretty good. Should be able to tighten this now. Looks like this has improved the backlash somewhat. The axis lag setting is still 2.2 thou, and if you move in 0.1 thou steps, we get almost 1 thou per step. So let's try reducing the axis lag now. Universal comp R Y 0.0012. There we go. Let's see what that does now. Let's go in 1 thou steps. Let's see. Not quite enough still. And the setting of 1.4 thou seems to be just about right. That's 1 thou per step there. There's a few things I want to fix up in the back panel here. This cooling fan has been wired up simply between ground and one of the phases. That needs to be fixed. And I need to rewire in this mist coolant sprayer. This was in pretty bad shape when I got it. I've pretty much got it back in working order again. It's just not much in here. There's a few solenoid valves and a switch, basically. The switch is compressed air. And I got a new mist coolant sprayer. This just uses compressed air just to mist out a coolant oil over the part, and you don't want to flood it with too much coolant. And they disconnected the wire going to it, but at least with these schematics, I've been able to figure out where it goes. The mist coolant sprayer is right here, and it connects sort of around where the flood coolant pump relay does. There's some 120 volt signals here coming from the servo cabinet. These are switched by the spindle drive. So when the spindle drive's on, the coolant is on. So I just need to find this one. Looks like it connects to connection 104, and the other one connects to connection 2, which is sort of common. Now these schematics are not exactly correct. This is for a slightly newer version of the machine, the one that has the Delta 20 control, whereas this one has the System 20 control, which is slightly older. So the control wiring stuff, which is a bit farther up here, this is not quite correct, but all of the back cabinet wiring stuff here seems to be right. Okay, the mist sprayer is wired in between 106 and 2, and I've reconnected this fan, or just basically rerun the cable down the cable tray between 130 and what was it? And 2. I thought this was actually thought this was one of the 3 phases, but no, this is the fuse for the 120 volt output of a 120 volt transformer that's in the other cabinet. So it actually was connected properly to 120 volts. It just the ground is the neutral, but it's best to connect it up to the proper neutral number, the wire number 2, rather than this just the ground wire. Next thing I got to do is adjust the spindle speed a little bit, because it's running about 10% too fast for some reason. And I don't have a tachometer, so I'll just tape a magnet to this and use the oscilloscope to measure the frequency of the coil next to it. That's running 3000 RPM now, and on the scope we measure 57 Hertz, where it should be 50, so we'll have to trim the speed down a little bit. Now we'll adjust RV9 or RV11 to get the proper spindle speed. Now I don't know if it's RV9 or RV11 because one is for forward, one is for reverse, so we'll just have to try one. There's additionally that seems to be RV9. There's RV9. There's RV9A and RV9A and RV9B for some reason, which both seem to have about the same effect on the control. I'm thinking one would be a coarse, one would be fine. Maybe we'll try RV9A. So RV9A doesn't have enough adjustment range. Let's see how much adjustment range B has. B doesn't have enough range either. Okay, I'll try adjusting RV1, which is the input gain control. That seems to have a bit better range. I may as well set RV9 back to the middle. now we got 30 hertz at 1,800 RPM. Now we'll have to do reverse. That's back in a better range now. The reverse speed is now 29.6 hertz, so let's go up on RV11. So on RV11 is not affecting it at all. I'm thinking that this is operating in a little bit, operating the drive in a little bit different mode, is putting minus 10 to plus 10 volts in and not using the reverse control. So I'm thinking that the drive is always in forward, so we only have one control really. We'll have to turn the speed up a little bit, see if we can sort of balance it out between the two, forward and reverse. I know there is a slight offset between the forward and reverse that we measured last time. That may be causing the measurements to be slightly different. There's a vibration problem on top of the machine here, and earlier I'd worked out that it's due to the imbalance in this pulley. I think it might be due to the keyways, because this spins at 8,000 RPM at full speed, so balance is pretty critical. There's definitely a lot of vibration in the head, and right up here you feel it on the motor frame quite substantially, and the frequency is too high for it to be the about 50-55 hertz spindle rotation, so it must be the motor's imbalance. And I had taken the pulley off the motor previously and the problem was gone, so it's not something inside the motor. I played around with putting different washers and different bolts, and this is about as good as I can get it, but it still vibrates quite a bit. So I think what I'm going to end up doing is making a shaft piece that fits in here so I can actually do a proper balancing and drill the pulley to balance it properly. The problem is not the motor shaft run out. That is pretty much almost zero. The pulley did have about 2 or 3 thou run out, so that might be just the problem with the pulley. Whatever it is this material is made of, it just destroys these cheap Chinese end mills, so don't buy these ones for anything harder than pretty much aluminum. Yeah, these cut aluminum fine, but they just dull up almost immediately on steel. I went and bought a locally made cobalt steel end mill and had no problems on on whatever this is. Too far there. Yep. This is very clearly unbalanced. You can see it sort of seesaws back and forth. Well, I suspect if we once you drill it out sort of evenly, we can drill the heavy side is on the bottom, so to drill out around these areas, it should be balanced better than before. Because before we had the weights all on one side, so it was sort of lopsided. That was a lot of holes to drill, but it's now finally balanced. Okay, let's see how this does. Oh wow, that's so much better. There's no vibration at all now, or only the tiniest bits. I can't believe how bad that was before. This is 3,500 RPM max speed, and it sounds nowhere near like it was sounding when it was running before. Yeah, almost no noise at all. Wow. Let's try some more machining now. I've got one of these floating tap holders in, so let's give that a try. This is basically just a Cat 40 tool holder that holds these little collets, and these hold a tap. And the collet holder, the holder sort of floats, so you get rotationally it's locked, but it can spring in and out. So if the feed rate is not exactly matched to the rotation, it won't break the tap. Because this machine doesn't have rigid tapping, where rigid tapping would exactly synchronize the z-axis to the multiple of the spindle rotation. Actually, this has got to be a drill first. We'll also try out the spray coolant system. I just got it hooked up to a temporary bottle up there. I'm just using the water-soluble coolant, or the coolant, cutting fluid in 5:1. I know that's not the right thing, but it should be better than nothing for now. Turn the spray down a little bit, hopefully. Don't need quite that much. Get a little closer. Maybe down there. And we have one of those axis lag problems again. Looks like we didn't drill these holes far enough, unfortunately. I'm just going to manually finish off the last little bit of these. Just didn't quite get them all the way through. seems to be working pretty well. Ah, beautiful. Works perfectly. I think we probably could have run that quite a bit faster. That was a pretty conservative tap there. That's enough for tonight, I think. Next thing is to look into adding a hand wheel to this control, and I think the schematics do have some clues as to how to do that. Anyway, thanks for watching.